Welcome back to another beautiful Monday, and I'm running a little bit late today. I've been running late for a few days, but I wanted to make sure I got Monday's morning's CAD tutorial out sometime Monday afternoon. So we're going to talk about some link brackets today, some super basic stuff. But first, do me a favor, if you haven't yet, subscribe to the channel, comment after the video, like the video, tell me what you think, and let's see if we can't teach you some things. Now, the easiest place to start is just drawing another tab. This is just like the shock tabs. If you go back into my videos, shock tabs, it's the same basic idea. In this case, we're going to use a 1/2 inch center bolt and a 2-inch diameter around our, say, bushing to use as our basic tab. Now, building a tab like this with a flat bottom, if you were to use a pair of these tabs, they are just going to line up 90 degrees perpendicular to whatever they're going on. In this case, right now, I'm going to show you a simple under the frame style bracket onto the face of something. I like building brackets where they're one piece. So if we take this bracket and we're going to fold it into shape so you can see it in 3 dimensions here. I like brackets that fold. So basically what I'm doing here is I'm going to fold these over 90 degrees. We're going to extrude these and show you what this bracket looks like. It's a whole lot easier to visualize in 3 dimensions. Once you get the hang of it, I program mostly in 2D. Sorry if I'm kind of programming faster than I'm talking here, but a lot of this I've kind of halfway covered before. Basically what we've got here is, say, similar to a leaf spring hanger, 3-inch between the plates for a 2-inch diameter bushing. This will fit a standard modern Chevy bushing. But if we flatten this out, remove the center here, this is how we're going to make this bracket so that it folds over. Explode the lines there, and we drag these lines in. I like to leave at least a 1/4 inch of material. I usually eyeball this, but for the sake of what we're doing today, we're going to leave a 1/4 inch of material past what will become a slot. I can delete the bottom edge because the mirror command takes care of all that. We're going to draw a line down here 3 inches, another line down here 3 inches, and if we select the whole top section here, we can mirror that, and what we end up with is our bracket exactly how we can send it off to the plasma cutter to be bent or cut out, and they'll send it back so that it can just be folded, welded, and it's good to go. It'll look just like the 3-dimensional drawing. Now, that's kind of a goofy bracket. Normally, I'd make them longer. So let's take a look at this. Let's say we want the same bracket, but we want it 5 inches long here so that we've got kind of a tapered angle on it. More of a conventional leaf spring hanger. If you do 4-wheel drive stuff, you'll know exactly what I'm talking about. These are pretty common in leaf spring kits. I drawn a 5-inch line straight down through the center. I don't like the bend mark being on a point, so what I'm doing is I'm extending it up a 1/2 inch and then coming over to the tangent on the circle. Now, we've talked about tangent before. This is how we make everything flow. It just makes the radius flow straight across the top. Select everything, use the trim tool, and we're going to remove the offending lines here. And I'm going to mirror our slot here. Now, these slots, when they're cut in, this gives us a place to bend, but as we can see, there's too much of a gap in the middle there. It would be a fight. I like having it so you can grab it with a crescent wrench once it's in the vise and just fold it over 90 degrees. 1/4 inch gap does that just fine. So it was 1.5 inches. We want a 1/4 inch space, 1.25 inches. That means we're extending each of these lines 5/8 of an inch. Double check our gaps. Again, I eyeball these. This is for the benefit of the video. But we go back down to the bottom, delete the bottom, mirror this, and now we have a bracket that looks more like a conventional bracket, gives us a little bit of meat, and lots of surface to weld to the frame. Now, since my background is heavily in 4-wheel drives, a bracket like this works, but it has a tendency to get smashed up on the rocks, and it doesn't generally look quite as clean when it's open like that. Just my personal preference. Since we can't just fold our box plate in, I like to use tabs and slots, tabs on tabs. So what I'm doing here is I've rotated the entire bracket till this line is flat. It makes it easier to lay all these lines out. We're planning on the bracket being a 1/4 inch thick in this particular case, so what I've done is I've marked a step up, a tab. It's 1/8 of an inch up, 1/4 inch across, and I've copied that down the line, and it's given us 2 tabs up. If I draw a line that down over a 1/4 of an inch and back up 1/8 of an inch, I can actually go in here and draw the edge of my box plate, the plate that we would drop on top to weld it. I go over, back up. This will give us another tab that'll key into the first one. Doing it this way is really nice because we know that the box plate is going to fit our bracket because we're drawing it right on our bracket. We can mirror it across because it finds the center of that line, draw a line to connect the two, and we already have one side of our boxing plate. This happens super fast. If I miss anything as I go, comment below and I can go back and answer any questions. But we know that this bracket is 3 inches across. We draw a line up 3 inches, mirror our lower plate on the line, take that line, mirror it across our bracket, join all those pieces, well, without grabbing the rest of the bracket, join those 4 sides, and we now have our boxing plate. Just that simple. Drag it out of the way. We can rotate this bracket back to flat. That way it's easier to use the mirror command. And what we're going to do is we're going to do just as before, delete the bottom section, grab the whole upper half of the bracket, mirror it back down, join everything together, and we have a slotted bracket ready to accept our boxing plate in about 2.5 minutes, which I flipped it into 3 dimensions here so you can see. The reason I don't go the full 1/4 inch, this means that our weld can completely cover the tabs there. We can grind it all out smooth. There's lots of penetration. We can do this with whatever material, but for suspension brackets, this works phenomenally well. So moving right along here, super common bracket, guys with trucks. I used to make a ton of these. This would be similar to a radius arm bracket, the kind of thing guys use on their front beam axles in some cases. Super common on a rear axle if you're doing a wrap bar on a big truck, an anti-wrap bar. You know, lots of big diesel guys will run these. This is essentially the bracket that would go onto the axle. I use Chevy Energy Suspension Chevy rear leaf spring bushings. All of them in the bushing kits are the same. And when you buy universal bushings, that's basically what they are. It's a 2-inch overall diameter bushing, fits in a 1.5 ID tube, and they're 3-inch mounting width. So looking at that, that's what this bracket would be designed to take, is that Chevy bushing. We're just spacing the holes out here. The same commands over and over again. Lots of circles, lines, the trim tool to remove the inner pieces. We're going to go in and fillet the edges, more for style than anything. It just looks like it flows. I don't like to leave the points where they meet the axle tube, so I usually go in and give them an 1/8 inch radius, just like this. And I mean, as fast as I'm trying to explain it, that bracket's already designed. We're going to flip that up to vertical, and we can extrude that with the extrude command, 1/4 inch thick. We're going to copy it 3 1/4 inches apart, so 3 inches between them plus a 1/4 inch for the material, and that'll give us our 2 brackets, 3 inches between them, set up to take a leaf spring bushing. And if we drop these 2 brackets in line, we're just going to move it over to the bracket. That way they are in line with it. And just drag it out so you can have a visual. But right there, that is what it would look like if you were building a wrap bracket, a radius arm front or rear suspension. You know, we use radius arm stuff quite a bit in hot rods, off-road, tow rigs, you name it. This is super common, super easy to design. So that's all great if it's straight, but what happens if you're working on an angle, because most things aren't straight, and I don't like misaligning bushings. So I'm going to show you 2 ways to do it. The first way is we take a line, draw a box, our 3-inch width, we put it on the line, and we're going to rotate this box. In this case, we're going to rotate it 20 degrees. Now that box is going to cross over the line, and if we take the aligned dimension will measure along the line on the same angle from point to point. It'll give us our straight dimension. We knew that that side was 3 inches, but we can measure the other side is 1.91, meaning that when we twisted it 20 degrees, that bracket became 1.09 inches shorter. Now this is important. That means that if we design our bracket 1.09 inches shorter, one side than the other, when we drop it up against the tube, the surface, whatever, we could make these so that they're flat bottom, we can make them round bottom, but the magic there is at 3-inch width, 1.09 shorter on one bracket than the other will mount up at a 20-degree angle. We could set that angle to whatever we want. No matter what the angle is, we could set it to 22.7 degrees. It will give us a dimension that's going to put us there. Now, these brackets are pretty straightforward. Basically, you know, if you watched my previous video, which I realize these aren't nearly as common, you know, they're not nearly as popular as the videos of me out smashing metal, but I feel like this is a resource that when people realize I can show them, they will start to pick it up. This is becoming super common for guys to design their parts. I think this will help a lot of guys down the road. Now, just throwing the numbers up there for the visual, we know that if our one bracket we just set up is 1.25 inches from the center of the hole to the edge of the axle tube in this case. If we add our 1.09, it has to be 2.34, so we can copy the bracket over, move that down 1.09. We're going to use the linear dimension to double check it. We have 1.25 there and 2.34 there. It matches the math. We know this is all good. So now we can finish out these brackets. Just like the shock tabs, when I'm doing something like this, I like to grab a line from the center of the tube and draw it out to the tangent. In this case, because the upper diameter is smaller than the axle tube, you can see the line crosses over. It means a couple extra clicks with the trim tool. But super simple. It's not a big deal. I mean, I'm talking here, and literally this video is running in real time, and probably a little bit slower than I normally do it, just because I'm trying to make sure that the screen is zooming in on what I want to be able to show you guys, and to give me enough time to explain what I'm doing. This process is super, super fast. And I mean, right there, we're going to use the fillet tool, round over the edges. The plasma table doesn't really cut those sharp edges nice anyways. It burns them away. So I like to round them over. It just feels cleaner, uses less material depending on how far those stick out. I just like the final product. But I'm going to demonstrate here, because the lengths are different and the way we're getting the edge lines. If we're to move one over the other, you can see if you were to try to box these in, now a MIG welder will fill the gap just fine. It's not the end of the world, but it's not perfect, and on bigger brackets it starts to become an issue. So since we have the capability, I'm going to show you a better way to do this. This uses a lot more three-dimensional stuff. If I'm doing brackets that I need to fit every single time, that I don't want to grind, touch up, or fill the gap, this is the way I do it. So what I'm doing here is I'm going to draw that exact same bracket, except this time I'm going to draw it 2 inches tall, just like the bushing. I'm going to make it quite a bit longer than I need it. I cut out the bracket. Now this just looks like a tab that would mount to something flat. I'm going to draw the center box in plate, which in this case, I'm going to draw it in with a little notched out piece in the middle. It's basically for style points, no other reason. Sometimes it's to clear grease fittings on a rod end or a joint, or if you're running a heim, it gives a little bit more room in the middle. You can box it further. For the purposes of this, I just think it looks better. But what I'm going to do here is I'm going to draw out my middle piece. I use the curved line tool, send my point. I don't like that, so I'm just going to grab the control point. I'm going to move it down until the curve looks pleasing. I'm going to join this whole piece, because what we need to do is we need to turn these into solids. We're going to rotate this piece, make our three-dimensional part, We need it rotated down 90 degrees. Our upper box plate is 3 inches wide, so we can extrude this 1/4 inch. And we're going to extrude the top surface. And while we're at it, we're deleting the poly lines that we used to make the solid. We want to get rid of those because we're going to create new poly lines. We're going to mirror that piece there. And we're going to create a cylinder. This is the 3-dimensional bracket before we've done what we need to do with it. This is our base. If we go up into the solid tools, we can collect cylinder. It doesn't screen grab that, but we're just grabbing cylinder, a start point on the edge. We want a 3-inch diameter, and all we care about is that it is longer than we need. So we will drag it back till it covers both sides of the bracket. We're going to grab our bracket assembly, select the edge. Now we could move this in and out, set our depths. For these purposes, the theory is all that matters. So we're going to rotate it that same 20 degrees. So now what we have is we have a 20-degree bracket. You can see it's actually long enough. It's poking out the other side. But that is a bracket that's 3 inches between with a 1/2-inch hole that is 20 degrees angled to the imaginary axle tube. We're going to select all of that, go up to our solid menu, and go down and click difference. It'll say select the other solid. We select the solid, delete input yes, and that removes all of the interfering metal. Super handy because this is how you tell when things run into each other. But now we're working in 3 dimensions, and if you look on this bracket, you can see obviously where the material that we removed was not perpendicular to the metal. So what we need to do is we need to put these all straight. We twisted it until the bracket is perpendicular this way. We're going to rotate the sides up. Now in the grid mode, in the top 3 windows, you can see through how there's multiple lines. On the solid, they don't show through. It's how I have it selected. I have it as shaded up top and polylines on the rest. But I'm zooming in here, you can see how on that bracket, the upper line is the one with the most removed, the other two, the lower side. Why this is important is when we cut our piece, we want to do it to the edge that has the most removed. That way it butts up against the tube the way we want. So for right now, I'm just sliding this out 1 inch. I'm going to slide the other side out 1 inch. And we're going to go up to our curve menu. And we're going to go curve from object and then duplicate edge. Now, once we click the duplicate edge, it's going to say select the edges that you want to duplicate. And we're going to go over there. We know on that one we want the bottoms. We select them and it highlights it. Click enter and it created polylines from those edges. Do the same to the middle piece. We can see it's the piece with the most removed. And we're going to go over to our last section here and do the upper because that's the one with the piece most removed. Now we can go back in and delete our solids because now we don't need our solids anymore for our purposes. And we have 3 sides of a bracket that are pure polylines. Type in project to C plane, delete input, and on the front or the right view, you can see where as we did that, now everything's on the same plane. We can delete the inner line of that bracket. We don't want duplicate lines here. And then we're going to move the pieces back in the 1 inch that we removed them. Moving them back in that 1 inch gets us where we were before. Now when this bracket folds over, it will be 3 inches apart. But you can see when it removed material, the way it removed everything is because that one needed more material off. It left us with a space. So we need to go in and fill that space there, fill that void. And we're going to trim out the middle pieces of these brackets because we want one solid piece that eventually we want it slotted. So we use the trim tool. We're going to remove the middle pieces here. Now, this is where normally I would just eyeball it. I would grab a line, but we know those straight lines from our middle boxing plate is where we need the bend marks. So we're going to draw a line between, grab the line, use the edit points, move it down 1/4 inch. That gives us our 1/4 inch gap. And we're going to do that on the same on the bottom end here. And then we're going to do it the same on the other side. What we've essentially done is we've taken a polyline, used it to create a solid, which we removed all the differences from a 3-inch solid cylinder mimicking our axle tube. Now, if you take this file that we're finishing up right now, you take it to someone with a CNC plasma table, a water jet, a laser, whatever, and they cut this out of 1/4-inch plate, you could stick this in the vise, and it would specifically give you a piece that when you fold it over 90 degrees has a 3-inch mounting width and will butt straight up to a 3-inch tube at 20 degrees. Just that simply. This is the complicated way that I do it, and it's still, I believe that entire thing took about 7 minutes if I actually looked. Now, if you take those skills and you start to expand on them, these are actually the brackets that will be cut out to go onto the rear axle of my 39 Chevy Businessman's Coupe. I designed these specifically for this car to line up where I want the links, and they will be going on this housing. Now, this housing is also a design of mine. I'm working in conjunction with my buddy down at Backdoor Fab, and at some point these housings will go into production, mostly for off-road use, but this is something that we wanted for us, and this is how far you can take these things, and this is not even as far as we really can take it. Now, I know that moved super fast. I know that I was trying to squeeze in as much information as I could, and I hate making these videos too long. I hope everybody got something out of this. If you did, do me a favor, like the video, comment below, ask me any questions you got, subscribe to the channel, share it around. Let's see if we can blow this thing up huge. I'd love to pass on as much as I possibly can out of my brain. If there's things you want to see, let me know. I'll try to cover them, and I'll see you on the next one.